Hello, good morning. Welcome to the lecture on distributed networks. Given this is the first lecture, we will just go through an introduction and go through some of the different things that we will be covering in this semester in distributed networks. The main thing is that many of the topics that we'll be covering will be sort of continuations from topics that we have covered in the previous semester courses. So like in advanced networking and so on. So we'll continue from that in many ways, and we'll cover a number of topics that are relevant to building more larger networks. So we looked at the basics of networks, networking, routing and switching in advanced networking. And in this course, distributed networks, we will look at how those networks can be expanded into larger networks. So that would be the main aim of the course here. And in terms of the mode of delivery and the activities and so on, we will discuss them at the end of the main discussion today. So one of the main things that we can see, so when we started looking at networks, we were thinking about say network in an organization, network at home. So in many of these situations, we were thinking about a local environment where there were a number of resources and they were interconnected. And then sometimes they were interconnected to a larger network, to a wide area network like the internet. But when we think from a business perspective, when we think about large organizations, they have a significantly different requirement in terms of building larger networks. It's not that they will need a small network or a large network. It would be that they would need both sometimes, or sometimes they may start with a smaller network and they may need to grow into a larger network. Say, for example, an organization may start in Sri Lanka, in Colombo. They will start their first branch in Colombo with a number of users there. And then they may open a branch of it somewhere else in another district. And then they may need to connect those two branches. Then they may hire more people. They are getting more business now. So now they are expanding the Colombo branch into more floors of a building. So now they would need to cater to more number of users. So what this means is the nature of the network that is required in a space itself can change over time. So if they started with 10 users and then now they need 100 users, these two networks are significantly different networks. A network that is having 10 users can be categorized as a small network, whereas if there's 100 users or 500 users, that cannot be considered a similar type of network. So now that is in a different category of networks. That is one of the main things that we will encounter in the business environment. Then another important thing, as I said, is what are the type of interconnections that we may need. Again, when the organizations are scaling up, when the organizations are growing, they may now need to connect to a number of different sites, for example. Say they may want to connect to, say, if they start in one city and now they are expanding into a number of cities. So now they may want to connect all of those things, like interconnections between all of those. Then one of the other sort of phenomenon that is happening a lot these days is people may want to connect to these networks from their homes or their other private networks, not from the organizational network. So we need to cater to such requirements in our network as well. So say if we started with a small organization with 10 users, it would be sufficient even to go with a small like a small office type of a wireless router, which may also have some wired connections, and that can connect all the users in the environment. But the same devices or even the same network plan may not work when we need to grow up like this, grow into a larger network like this, uh, interconnecting other sites, interconnecting external users, and so on. We may need much higher level of networking capabilities. So that is one of the things that we'll have to think about when we are thinking about large scale network, because not all large scale networks start as large scale networks. Some would start as small networks and then scale up into larger networks as businesses grow and circumstances change. So this is the main thing that we'll be focusing on in this distributed network course. What are the things that we need to do when we are building larger networks or when we are expanding into larger networks? Then one of the other things to remember when we are talking about these type of larger networks, enterprise networks, is what are some of the needs in such networking environments. So one of the main things that we would expect to have is these networks support a variety of network traffic. So for example, if we consider, say, an organization, they may have a number of different types of traffic happening. So they may have different applications for their business purposes that their internal users are using. So that may need some network traffic. There may be external customers connecting into the organization. That may be a different type of network traffic. There may be voice over IP, video conferencing, these type of other multimedia type network traffic that may have different requirements. Then we may have other peripheral equipment such as CCTV cameras, security systems, and so on, which are also connected through the IP networks. So now, when we think about this type of a large enterprise environment, the type of traffic that needs to be supported is going to be much more diverse. It's not just going to be web traffic. It's not just going to be a single type of traffic. It is going to be a variety of different applications, services, and so on that are being used inside such an organizational environment. And some of these applications and some of these services may be business critical. For example, there may be servers that needs to run 24/7. There may be other applications that need to have certain level of availability. So there will be certain business critical applications in these environments. And in many ways, we will use these networks in a converged manner. So what we mean by converged manner is, for example, there was a time period when the data networks and the voice networks or the telephone networks were separate in most organizational environments. But that is not the case anymore. These days, the norm is that voice over IP based systems are used commonly for telephone purposes, and those are also connected through the same interconnectivity networks. So the same local area networks would connect both data networks and voice networks. So these type of different requirements, different needs that we would have from business entities will have to be satisfied by the networks that we have in those environments. So regardless of whether we are operating in a single site or if the organization has a number of branch offices and all of them are connected together through a wide area network through the internet, we would still need to have all these things working together, this larger expanded network working together and being able to administer and manage them more effectively. But one of the foundations that we should remember is anything that we discussed, anything we have covered previously, all the fundamental things that we have discussed previously about local area networks and so on are still valid even when we are growing into larger networks. So the basic fundamentals are still there. Even in larger networks, at the very end, they are still going to be local area networks. They are still going to be smaller networks, which are interconnected to build these larger networks. So that is going to be still there. So we'll start from these smaller networks and then we build into larger networks. We scale up into larger networks. So that is how we would try to build larger enterprise networks ideally. So this is something that we have covered previously as well, the hierarchical design model for a campus network or an enterprise network, where we break the network into a number of layers, and each layer will have a different functionality. Each layer would do different things in such a network. So instead of having everything connected to a flat layer, which means, say, if we think about a home network, all the devices are connected to a single device, which acts as the access point, a switch, and a router. So all of these things are connected together. But whereas in a larger enterprise network, we would ideally want to break these things into different functional layers. Each of those things will implement different functions from the point of view of the larger network. So this would make it easier for management purposes, easier for expansion purposes, scalability purposes. There will be a number of advantages why we would do this. So this is something that we have briefly touched upon previously as well. So I hope you all remember that. So the main three layers that we would identify here are the core layer, distribution layer, and the access layer. And all the interconnects would happen through all these layers to the outward networks. And then we would also talk about building redundancies, redundant pathways, and so on will also be part of this hierarchical model. So when we think about the access layer, the main purpose of the access layer is about connecting the end nodes to the main network. So that provides the last point of connection to the end nodes. So the computers are the devices that are there. So this is the one that is going to provide that last point of connection to the devices. And it would not do much of a routing at that point. So not much of a routing information is happening at that point. It is mainly going to be switching applications at that access layer, and it is going to be mainly about collecting the traffic at this end and then forwarding it to the upper layer of distribution layer. It would have certain functionalities because it is going to be the one that is connecting to the devices. So it will have certain functionalities about access control. So this layer is the one that will control which devices can and cannot connect, and so on. So those type of things can be done at the access layer, and in certain cases it can also add certain additional features such as tagging and so on, which some of these things we will discuss in a bit more detail later on in this course. Then the distribution layer is going to be something that is sitting in between the access layer and the core layer. And the main thing the distribution layer does is about isolating the topology changes. So that is, say, even if any of these topologies are changing, the physical structure of the network or even the virtual structure of the network is changing at the access layer, still the distribution layer can still remain same. So it will still remain same, and it can provide the same view to the core layer. So the core layer doesn't need to know any of the changes that are happening at the access layer or at the node levels. The distribution layer will manage that. So it will isolate the topology changes above. and then it also will aggregate all the traffic that is coming from the various switches in the access layer and below, and then it will forward them as a single path to the core layer. In some cases, it may do additionally route summarization and so on. So that is also possible. So that is the main functionality of the distribution layers. It mainly sits between the distribution and core and the access layers, and sort of provides them services or functionalities to both of them. And the core layer is the one that is mainly responsible for forwarding packets. So that is the one that is going to figure out where the packets needs to go, know about the networking, all the network policies, identifying all the routings, preventing routing loops. So all the main core functionalities of the network will be done at the core layer. So that is how we would separate these three layers in the hierarchical design model. And in some cases, what we may also do is we may sometimes not have these three layers, but we may collapse them into two layers. So we may have a core layer and everything else is part of the distribution layer, or we may have a core layer and a access layer. So so that is also possible. So depending on if the network is not too large, if the network is if it is a very large network, we may go with the three-layer hierarchical design model. But if that is not a very large network, we may sometimes go with only two layers, having either core layer and only the distribution layer, or having the core layer and only the access layer, and everything else is connected to the access layer. So again, not having three layers but just two layers. So that's the main difference, and that is possible and sometimes viable if the networks are not too big. So if it is a very big network, very large network, we may choose to go with the three-layer architecture. But if it is not that big, sometimes depending on the requirements and so on, we may choose to go with a two-layered architecture as well. So the next thing that we will look at when we are discussing about building enterprise networks, building large-scale networks, is the ability to scaling up. So that's what we meant. Say we start the organization with say 10 devices, and now we need to grow into 100 devices. So that is the ability to scale up. So if there is a plan for the organization to scale up, then we may have to consider that even at the initial stages of designing the network. Say for example, if it is a home network, if it is your home, there's not a likelihood that you are going to get 100 users at your home. So that is how it is, because that environment doesn't have a scope for growing there. Whereas if it is say a startup may start with 10 users, but then if the business becomes successful, then they may want to grow, hire more people, build new departments and so on. So now they may need to cater to more number of users. So if you want to plan a network ideally from the beginning, you would consider that. You would think about if there's a need for scaling at a later stage, and we would design the network in a manner that is scalable at a later stage. So we would design them using things like expandable modular design equipment. So like say having switches that can be, more ports can be added to switches, or more switches can be connected together. When we are deciding on IP address strategies, again we will choose suitable IP address strategies local IP address strategies and so on to cater to expanded larger networks, and also using certain other networking capabilities such as multi-area networks and so on. Some of these things, again, we will discuss in much more detail as part of this course, particularly multi-area networks and how routing and things are affected when we build networks in such a manner. So we will discuss some of these scalability aspects in a bit more detail later on in the course. One of the main things that we will need to do in terms of scalability is one thing is about having devices, having a hierarchical network, having devices that can be upgraded or added, or like say if you have a switch, 24 port switch, can you add another 24 ports together with that in the same environment? Sometimes using wireless networks can be a way to expand the existing network. Choosing suitable routers and switches that can cater to that level of connectivity, using approaches such as link aggregation, connecting, having redundant links, and so on. So these are some of the capabilities that we may want to have in the large scale network. So we have to think about that from the beginning itself, so then we know how that can be at the sort of in the future, so to speak. So these are some of the strategies we may have to think when we are building these type of networks, and we will discuss those in a bit more detail later on. So one of the main requirements that we will have here in these type of larger networks is what is called high availability. So what do we mean by availability is the amount of time a network is available or expected to be available. So depending on the nature of the organization, this may change significantly. Say for example, if it is like a shop, like a local shop, that they have some number of counters, cashier counters and so on that are interconnected. So that network is critical to run their day-to-day businesses, but they only need that network while the shop is open. So if they are selling something at the shop, there are counters and so on, so they need the cashier counters and all these billing systems to work at that point in time. But when the shop closes, those devices are no longer actively being used, so there's no need for that network to be actively available. So the requirement there in terms of availability is only limited to a portion of the day. Whereas in certain other type of organizations, they may have a medium level of need. They may expect these networks to be available most of the day, and for example, mostly they want them to be available as much as possible. But say for example, if we want to have downtime for schedule updates or something in a minimal need network, we can do them at the end of the day, whereas in medium need networks we may have to schedule them for weekends. How the impact to the network will also differ from these different types of network. But one of the main considerations that we will have is about the high need networks, so networks that need high level of availability. So these are networks that need 24/7 access. Downtimes have to be scheduled much in advance. So like a banking network or an ATM network for a bank, there it needs to work 24/7. If the network needs to go down, then it should be planned accordingly and the upgrade should be completed within the given time. Network failure can be a big problem it can be a big loss of business and so on. So those are the types of networks that we can classify as high need networks in the context of availability. And how do we achieve high availability is using some basic techniques. One is having redundancy and resiliency. So that is having redundant pathways for network traffic, redundant devices, and so on. And so even if a single device fails, there's another device that can take up and continue the network connectivity. So if a router fails, there's a redundant router. Switch fails, there's a redundant switch, and so on. So we have everything is duplicated, so the network availability can be ensured at a much higher level. So it is all about reliability and having managing that according to the business need. So when we plan for redundancy in these networks, the main thing that we think about is about preventing disruption. So what would happen if one of these devices fails? Say if this device is no longer working, what is the impact of that? So that is the main thing that we are concerned about when we are talking about redundancy. So what we build or what we want to do in that situation is, one, build a duplicate equipment for that, so a parallel equipment as a duplicate for that, and then also having parallel connectivities. So it's not just the equipments are duplicated, but also the connectivity is duplicated. So if one of these things are failing, the other pathway can be chosen and still the network is active. One of the things that we will discuss later in this course is about some of the issues related to loops happening when we are adding redundant networks. But regardless of that, redundant pathways are an important aspect that we will have in many large scale networks. So the redundant pathways and duplicate equipment are the two main things that we would need to have redundancy. Another related concept to redundancy and availability is what we call as failure domains. So what we identify in a network as a failure domain is what happens if a device fails and which parts of the network will be affected by that. Say for example, in the network here, what we have here is, say if this switch 1 fails, anything that is connected to switch 1 is going to lose connectivity. If switch 3 fails, anything that is connected to that is going to lose connectivity. Whereas say if switch 2 fails, anything connected to that and it is connecting to switch 3, so these are also going to be impacted there. And if the router fails, now all of these things are going to fail. All the connectivity from all of them are going to fail. So that is the failure domain. So the failure domain for this particular router is all these devices, whereas for this switch it is these devices, and so on. And what we would ideally want in a network is to limit the size of failure domains. So we don't want many things failing just because one equipment failed. We want to minimize how many things are affected by the failure of a single device. So that is one of the main things that we will want to do in a well-designed network. The reason why we want to have smaller failure domains is, say, if it is only impacting a smaller portion of the network, then we can easily troubleshoot and identify where the problem could be, and that can be fixed. And also, in terms of availability and so on, it is still only some of the devices are going to be impacted by that failure. If we have everything connected to a single device and that device fails, a lot of things will be impacted. So that is one of the reasons why we would try to spread out the network to smaller failure domains as much as possible. And one of the other things that we would do to remove or reduce the failure domain sizes is about using redundant links. So if we have a single router here, if that one fails, all of these things are going to fail. But if we have a redundant router in place of that, now that can take when one of these things are failing. So the failure domain is now reduced. So the impact of the failure can be reduced in that case. So that is one of the main things that we will do when we are building these type of high availability, reliable networks. So one of the main reasons why the hierarchical design model is very commonly used is because of these failure domains, because of the way the hierarchical model is designed, and especially when redundancy is included in that, it reduces the failure domains to the very it contains them to the very lowest level of the switches for them, and at the high levels there are more redundant components, so the failure domains are eliminated or reduced to smaller sizes. So that is one of the main things that we would do in terms of achieving smaller failure domains. One of the other issues that we may come across when we are talking about large-scale networks is the issue of bandwidth. So for example, if we are interconnecting a number of devices, if we are converging a number of connections into single switches, say for example, if we think about a hierarchical network, and in a hierarchical network, we may start with the access layer, a number of devices at the access layer, and now they are interconnected to a distribution layer, and then they are interconnected to the core layer. So if they are interconnected in that hierarchical manner, what happens is, as they go up and up in the higher layers, the amount of traffic that is converged is higher. Say for a low level switch, there are only say 24 devices are connected, but such 24 switches, maybe 10 of those switches are interconnected at a high level, and even higher, there may be 500 devices in total connecting to a single, or traffic from 500 devices are coming into a single device. So that would mean the links that we have, the bandwidth of the links that we have may be limited. So to do that, to increase the bandwidth available, so if the bandwidth that we have is limited, physically limited by the link that we have, what we can do is we can do link aggregation. So we can aggregate two links, we can connect two links and make them function like a single link by effectively doubling the bandwidth that we have. So again, this is one of the approaches that we will discuss in a much more detail later in the course, particularly about link aggregation and ether channel and so on. We will discuss in much more detail later in this course. And then particularly about expanding or scaling up the access layer, particularly these days, one of the common approaches that is done is by introducing wireless access points, or wireless local area networks. The reason being, if we think about an organization that is already, the physical infrastructure is already set, and now if we need to scale up, rather than adding wired connections which may require a lot more physical labor and physical work and laying cables and so on. If wireless connectivity is okay for the users that exist in that space, we may go with a wireless connectivity option. So there's no need for all the cabling and all the physical infrastructure development is not needed, as long as those wireless access points can be connected together. So instead of laying so many cables to say 100 devices, we may connect to 4 different access points, and that's all. So that's a very different approach, but it has a lot of advantages, particularly when we are scaling up networks, and particularly these days with the common use of mobile devices, laptops and so on, which already have wireless connectivity or capability to connect to wireless networks. This is a very common approach that is used, particularly at the level of access layer, or expanding the last mile of connection to the end users. Then one of the other things that we may have to think about when we are thinking about large scale networks is about how we are going to manage these devices. So when we think about a large scale network with this hierarchical model, redundancy and so on, what we are going to end up is not just few routers or few switches or so on. We are going to have a number of these devices located in various places within the organization environments, sometimes even in multiple sites and so on. So now, in terms of how we want to manage these devices, we may have to have certain approaches to managing them, doing the administrative tasks there. There are two common approaches that we would take in terms of doing this. One is called out of band router configuration, and the other one is called in band router configuration. So the main differences is in out of band management, what we do is we connect through what is called the console port. So we will come and connect to the device directly, or we may use what is called the auxiliary port, and it may be connected through a specific network to our device. So that is one approach, but it will use a dedicated connection to do that. Whereas an alternative approach is what we call as in-band configuration. And in band management, what we do is we use either the Ethernet interface or the IP interface, and we directly connect through the Ethernet interface or the IP interface. It can even be the internet, and there we connect through SSH or sometimes even a secure web administration portal, and we can connect and configure, monitor and manage the devices. So this is again an important part of building larger networks, that we need to manage these devices, we need to administer these devices. And one of the common things that we can observe is more and more use happening, or preference going towards in-band router configuration rather than out-of-band router configuration, because we don't need any specialist connections or connectivity, and it can easily be connected through dedicated, say for example, these connections can be added to a dedicated VLAN, a management VLAN and so on. So those are some of the things that we may do when we are building larger networks as well. So again, some of these things we will again touch on later, but we have covered some aspects of these about management VLANs and so on previously as well. So one of the other things that we will have to think about when we are thinking about large scale networks, scaling up these networks, is about what are the type of devices that we may need, and what are some of the specific capabilities that we may expect from such devices. So when we are building smaller networks, certain type of devices may be okay, but when we are thinking about large scale networks, we may expect them to have certain other capabilities from a hardware point of view as well. So we can think about switches, routers, and so on, and we may expect certain capabilities from them. Say, for example, when we are thinking about switches, one of the main things that we will have to think about is what could be the need for scalability, what could be the need for expansion at a later stage, and thinking about what type of device that we want, whether we want a fixed or a modular configuration device, whether it needs to be a stackable or a non-stackable device, what is the physical size, and overall what is going to be the cost, post density, port density, power, reliability. So these type of things, because if when it is a smaller network, these things are not going to be significantly impacting, because say if we are only going to use 2 switches, we might as well go without thinking too much about those 2 switches. But if we are going to have 200 switches in an organization, then that is a very highly costly thing to procure. So too many devices, very costly, and also managing them could be an issue. We may have certain needs in terms of speed, bandwidth, and so on. So we have to consider all these things and then make a decision in terms of what is the most suitable device in a particular environment. So these are some of the things that we may have to think, particularly when we are thinking about switches. One of the important things that we will come across, particularly about switches, is about port density. So that is how many ports are available in a particular device. Say, for example, if we have 24 port devices, and if we want to connect more than 24, now we need to add another device there. So that is going to take up more space, could take up more power, and also cost wise also it could be an issue. Management wise also we need to manage one more device. So in that case, it might be more suitable for us to get a single 48 port switch rather than 2 24 port switches, if depending on our requirement there. In some cases we may go for, like, say, even larger modular switches that can even have up to 1000 ports. Again, depending on the type of the organization that we are thinking about, we could go with such options as well. So particularly in larger environments, we may go with more sort of modular approaches with expandable number of ports, so the port density can be increased significantly. But in other cases, sometimes we may go with fixed configuration switches as well. One of the key things that we will have to particularly pay our attention is about the forwarding rates of these ports, of these switches. Say, for example, particularly in the hierarchical design model, what we have is, particularly at the distribution layer and core layer, so when we go up, we are aggregating the number of things that are interconnecting. So when we go up, say for example, if our devices are connecting at 1 gigabit speed, and then if they are interconnecting, if we are aggregating them into another switch, and that interconnection is now going to carry all the traffic coming from all these devices. So we may need a much higher bandwidth connectivity between those 2 intermediary switches, or at the higher layer connectivity. So we may have to have more capable devices in terms at sort of distribution or the core layer compared to the access layer switches. So access layer switches only need to forward traffic coming from, say, 24 devices, whereas the same on the upstream, the distribution switch is now maybe handling 200 devices. So traffic coming from 200 devices needs to forward that traffic. So it may need more capability, more processing power, and so on in terms of the actual device itself. So those are some of the things that we may have to consider there as well. And one of the other things that we will discuss a bit in more detail later on is about multi-layer switches, or switches that can do layer 3 capabilities as well, not just layer 2 switching, but also some aspects of routing, some aspects of inter-VLAN routing, and so on. So some of these layer 3 switching capabilities is also something that we would discuss later on. And particularly of interest, particularly these days, is in terms of building larger networks, is the capability of power over Ethernet. So what happens is the switch connecting to another device, any device that is connecting the switch through the Ethernet, can be also powered through the same connectivity. So the power can be provided from the switch to the device for the device to be powered on. For example, if we have a IP phone, for example, either we need to connect that IP phone to a power point or a power switch somewhere, a power plug somewhere, or that power can be provided by the switch itself, so we don't need additional cabling there. Similarly, say if there's a CCTV camera, same thing. If the CCTV camera is anyway needs to be connected to the network, might as well send the power through the same connection, so it can be powered as well. So that is the capability what we call as power over Ethernet, and that would be a key requirement in many types of devices connected to sort of present day networks, particularly in enterprise environments. Things like IP phones, CCTV cameras, various security systems. Sometimes we can even power other switches through power over Ethernet connections. So that is also another requirement we may have in certain large-scale networks. Then, but in terms of large-scale networks, we also need to have routers. So routing is an important aspect of any type of network, particularly for large-scale networks. But one of the main things that we would need, or one of the main differentiations with these routers, would be, one is about their forwarding rates, the amount of bandwidth that they can support, but also the different types of media, different types of protocols that they need to support, and also the ability to have build sort of these redundancies, capability to do redundancy, and ability to connect these various types of networks, interconnect to other wide area networks, and so on, would be sort of the main requirement in these enterprise type routers. So particularly compared to sort of other small scale networks, and large scale networks would have certain additional requirements for routers as well. The main things that we would expect from routers is about broadcast containment, so controlling what is the broadcast area of a network. Security capabilities would be a key requirement in enterprise networks. Interconnecting between different locations is also another important aspect that may be required, and things like VLANs or logical groupings such as VLANs and so on may also be a key requirement in enterprise networks. So essentially these are some of the main aspects or capabilities of routers that we have discussed previously as well, but these are mainly required particularly in large scale enterprise networks. So if we are choosing a device for such a network, we have to think about whether it can support certain security requirements that we may have, certain VLAN capabilities that we may require, certain interconnectivity between sites that we may require. So these are some of the things that we will consider when we are building large scale networks and choosing a router device for such a network. So that is a brief introduction into some of the topics that we will be covering in this course. These are some of the other topics that we will cover in the coming weeks. some of these things we may go into a lot more detail. Some things we will briefly cover, and there would be another course later on where we will take up some of these things as well. In your final year, in your last semester, there are 2 other courses where some of these concepts will be continued on. But other than that, this is like the main plan that we have so far in terms of the topics that we are covering. And in terms of the main assessment part, I think depending on when the assessments are happening, things may change. The percentages may most likely will change, but as usual, as in the previous course, we will have some practical activities. We may have 5 or 6 practical activities, and we would also have maybe 1 or 2 quizzes or assignments, depending on how we go, depending on the topic areas that we are covering. But in terms of the main key practical activities, I will share as usual the packet trace activities, and the assignment submissions will happen as it used to be in the previous semester. And again, as usual, the main course resources will be shared on LMS, and the usual communication modes will be there. So I will message on LMS, and also we will use our WhatsApp group as well if we need to communicate. And the other important thing is, depending on the situation in terms of the reopening of the universities, we may start in-person classes at some point in this semester, but until that point we will continue the online mode of teaching, and at that point we can switch to in-class teaching. Any questions? So if there are no questions, we may conclude for the day. Thank you for joining, and see you next time. Bye.